Hello and welcome to Postgres FM, a weekly show about all things PostgreSQL. I'm Michael, founder of pgMustard, and this is my co-host Nikolay, founder of Postgres.ai. Hey Nikolay, what are we talking about today?
Hi Michael, let's talk about partitioning.
Absolutely. Table partitioning in Postgres. We've talked about it in a few episodes actually, mentions to it when it can be beneficial, but it's great to do an episode completely on this. We've had requests for it and I'm excited to get to it. Where do you want to start? Perhaps with what partitioning is?
Of course.
I can give it a crack. So my favorite thing about it is that description, it's about splitting a table into multiple tables, and the beauty of it is that that's transparent at the user or client level. Yes, exactly.
Because we can split ourselves. We can say like we have table name. We can do table name 1, table name 2, but it will be not interesting to rewrite our application. And partitioning does the same, but behind the scene, right?
Yeah, exactly. With lots of nice, cool features to come, and an ever improving list of features to go with that. Did you look into the history of it at all? And I mean, obviously, you've lived the history of it.
I lived through the history. I remember I was using inheritance-based partitioning and helped clients implement it. And this actually was my first real job in terms of Postgres consulting in Silicon Valley, one startup which moved from, actually I helped them move from Heroku to RDS. And also they had issues with large tables, and obviously I said like let's partition it, and that it was before Postgres 10, which implemented declarative partitioning. I don't remember, maybe it was Postgres 9.3, 9.2, so quite long ago, and we did it with inheritance. A lot of PGSQL code was written, and at that time, actually, the interesting part is this exactly the task when I realized that RDS regular clones is very good for testing. So I had many cycles of testing to have fully automated procedure, move old rows from old location from non-partition table to partition table in batches, to have view on top of it to provide full transparency for application. Everything is possible, but it took a lot of effort because inheritance-based partitioning, maybe it provides you more flexibility in some places, but it lacks automation. You need to write a lot of code. And of course, if you have clones, it's good. You can test it, but still it's a lot of work. And by that time already, I think pgPartman existed. I'm not sure RDS has it, but somehow I decided no. Yeah. Anyway, around 2015, as we also discussed a couple of times, a lot of former Oracle users or current Oracle users came to Postgres community and ecosystem, and they obviously raised the question, we cannot live without declarative partitioning anymore. It's not good. Let's do it. And declarative partitioning was implemented. I think it was in Postgres 10, right? First version appeared. But yeah, it should be. Maybe I'm wrong. But then in each version, a lot of new features related to partitioning were added. It means that if you own quite old Postgres and you are considering partitioning or to use it more often, obviously, first thing I would do to consider a major upgrade to the latest version possible, because it would provide much more features, benefits in this area.
Yeah. In fact, you mentioned it right at the beginning of that, but I think it's worth going back to. The benefit here is that large tables can get difficult to manage. So there's certain things that become very...
sorry for interrupting. I just realized, since you asked about history, the inheritance-based partitioning existed for long, and inheritance is a good concept. It's from the era when like object relational database concept was popular, late 90s, early 2000s. But declarative partitioning is much easier to use, right? And now, of course, I would not use inheritance-based partitioning at all, except some rare cases. But let's talk about why do we need it at all. What do you think?
Yeah, so I mean, I bump into different reasons that people want to do this, but the main one I see is maintenance. So easier and more parallelizable maintenance, ability to... So that includes things like indexing, re-indexing, vacuum, analyze, probably a bunch of things I'm forgetting there. But in addition to that, if you have data that needs to be deleted, so old data or a certain client, like if you might want to partition based on how you want to. Yes, so we have the ability with partitions to detach the partition and drop the entire table, and not have to worry about the deletes and the impact of all of those. So
or just truncate particular partition and that's it, because truncate is much faster than delete and then vacuuming, because delete doesn't physically remove anything, it just marks tuples as deleted, and then it's heavy operation if you have millions of rows.
Yeah, exactly. So I think you still detach first, right, before truncating? But
well, nobody prevents you from truncating particular partition. Why not? But it's a good overview. But I would like to emphasize that most people think, many people, not most. I don't have statistics in hands, but usually people, from my perspective, they think partitioning is needed for query performance. It's so, but not so, like direct. There are direct and indirect benefits for query performance if you use partitioning. Direct benefits is, of course, indexes are smaller and faster. Good, but we all know that B-tree height grows very slowly. So you need to have, like, jumping from 1 million rows to 1 billion rows. It's just a few hops in terms of index tree traversal. But indirect benefits are much more interesting, and let's talk about them. You mentioned manageability, maintenance of partitions. Exactly. Like if you need to vacuum very large table, it will take hours. Sometimes half a day, sometimes like almost like a day. I saw depends on your system, on your power of your disks and so on, but it can take quite a long. But it cannot be parallelized in terms of heap and toss table vacuuming, right? And it's single threaded process, and you cannot speed it up even if you give. If you adjusted cost limit and cost delay for auto vacuum workers, so they go full speed, you don't care about negative effects. It's still slow because it's single threaded. If you have partition table, if you have, for example, 10 partitions, 100 partitions, you can benefit from many workers and to do much more work faster, right? Then it's question about your disk I/O limits, saturation risks, and so on. But you have flexibility; you can tune it already. So for indexes, it's better. But as I remember, you auto vacuum also for one table. It processes all indexes using a single worker. Only manual vacuum can process multiple indexes. In modern Postgres newer versions, it can be parallelized, right? So anyway, partitioning is much better for vacuuming. It's straightforward because parallelization. And I see due to defaults, we have only 3 workers by default usually. And it's so sad to see 3 workers on systems with 96 cores. I do it all the time. Somehow people think auto vacuum is good. Like if you have so big systems, so many vCPUs or cores, consider like adjusting number of workers earlier because it requires restart, right? Especially if you're thinking about partitioning. These things come together. If you are planning to use partitioning, you definitely need to reconsider your auto vacuum tuning settings and have more workers. I usually recommend up to 30% of vCPUs to set number of workers, number of workers for auto vacuum, and also like increasing other things. So this is number one thing, but close to it also, you mentioned index maintenance. Again, building an index on a very large table might take an hour or more, sometimes hours, like 8 hours. I saw it also. It's not fun at all. Especially it's not fun, unlike regular vacuum, index build or reindexing, concurrently or not concurrently, doesn't matter. It holds Xmin horizon.
Yeah,
we discussed it a couple of times. There was an attempt to fix it in Postgres 14.0. It was reverted in 14.4. All versions between 14.0, 1, 2, 3 are considered dangerous because they can lead to index corruption. So if you're Postgres 14 user, you should be at least at Postgres 14.4. It would be nice. Like, it was very great optimization not to hold Xmin horizon when you build or rebuild index. But unfortunately, it was reverted. I don't know the plans when it will be added back. But what does it mean, holding Xmin horizon? It means that while you are building or rebuilding your index, there is Xmin horizon. It means that there is some number in terms of transaction ID, XSEED transaction ID, right? Corresponding to the moment when you started to build the index. And all tuples which became dead after it cannot be deleted by auto vacuum or regular vacuum because Xmin horizon is in the past. So while you are building index on a very large table, vacuuming is less efficient and it cannot delete many tuples. If you enabled auto vacuum logging, you can see like some dead tuples are found but cannot be deleted. This is exactly because Xmin horizon is in the past for them. So, and this is a problem leading to bloat, right?
Yep.
Higher bloat that we could have.
Higher bloat that can lead. You mentioned second order effects or indirect implications. So we have bloat causing slower query performance. But also I had one more that I really wanted to mention. Oh yeah, so vacuum getting behind can lead to things like the visibility map not getting updated, and then that can lead to plans no longer being able to do true index only scans. So that can impact query performance as well. So like there are these other effects as well. So being able to parallelize vacuum and have more workers for doing vacuum on each partition it can be a benefit from that perspective too.
Right. So one of the things, if you have partitions and we don't there is some rule some people follow, don't allow tables to grow above 100 gigabytes. If you have 100 gigabytes, you need partitioning already. So yeah, right. If we have smaller tables, our auto vacuum workers are feeling much better, removing garbage much faster. That tuples garbage collection works more efficiently, and this affects query performance definitely. It's very hard and tricky to measure. Like sometimes people say, well, okay, how bad is that? Well, we can take some experiments and show degradation of some query performance, but it very depends on nature of data and workload. But I already feel it would be possible to develop some metric. For example, understanding the XSEED growth rates, like you're writing transactions, how many per seconds you have, XSEED growth rate is this, and you could have like some threshold saying, or SLO, SLA, with SLO probably. We don't want to allow our Xmin horizon to be these number in terms of XSEED, or this number in terms of minutes or seconds behind current value. So we should not allow Xmin horizon to lag that much. From this, you can go to the requirements of how big your partitions should be, right? Because like there is some math here. It's possible to develop for a particular system. It's very hard. It's much harder to develop some methodology for arbitrary system.
Right? Yeah, good point. In fact, that probably leads us.
That's why 100 gigabytes. Just 100 gigabytes. So good rule, right? But we can do better in terms of like explaining why this number.
Yeah, it's a nice, memorable number for sure. There's while we're on the topic of that when, I guess there's also the question of how, and I think.
One second. We didn't finish with why.
Okay, continue.
Very big reason also is data locality. It's huge reason, especially for data like time series data or time decay data, which has like these are new rows, these are fresh, and being accessed more frequently, and these rows are quite old. Maybe sometimes soon they will be not needed at all. We will consider pruning. It can be regular time series like measurements of temperature or something like metrics, or it can be also like social media comments and posts and so on. They also tend, like fresh data tend to have usage pattern like to be more frequently accessed. And we would probably like to have fresh records in our shared buffers and operational system cache and so on. And all the records, only few of them, and we could allow like higher latency, a little bit higher latency for all data, probably. It depends, of course. But if you think about very large table, we have everything like mixed. Any given page can contain new and fresh records.
It's kind of like a loose clustering. Like we don't have index organized tables in Postgres, but it's almost like it's not an enforced clustering, like in terms of strict, but it's kind of a loose clustering. If you think about the time series example, things aren't guaranteed to be in order within a partition, but each partition will be kept separate.
Yeah. So, actually, if you, for example, consider indexes, you have an index on table. You have, for example, something like date, creation date, and you think, okay, it would be good to partition by days or months or weeks. You could have all your queries dealing with filtering on date somehow, and then you could instead of partitioning on table, you could just split indexes to 10 or 100 or 1,000 indexes, partial indexes, like partition at index level, and it would work well if the only reason for partitioning was query performance, direct benefit from smaller index size. But as we just discussed, there are bigger reasons than just smaller index size. So you need to split tables definitely, and But speaking of maybe one more reason, like data locality is very important because if you consider like you have, I don't know, like a lot of heap only tuple updates inside pages and so on, but it's not good to mix fresh and old rows in one page all the time, like mixing in a huge table, because you need to allocate more memory to hold. For example, okay, I want all my fresh data to be in in the buffer pool, for example, closer to application. In this case, you need all pages, right, of this table. But if you start splitting by date somehow, fresh partitions have fresh data, old partitions have old data. For fresh rows, you have much fewer pages, right? I'm talking about cache efficiency here. Right, and in this case, also you mentioned all visible and all frozen. These bits for each page. It's a visibility map. It's very good to have all data separated in old partitions, because updates or deletes happen very infrequently there, or inserts also. And so we auto vacuum can skip many more pages, keeping them all frozen or all visible all the time, right? Much like it's also about vacuum efficiency, but a different vacuum, not deleting the tuples, but keeping this visibility map up to date. And this is super beneficial for performance, query performance, because visibility maps, like we can see for index-only scans, heap fetches in the plan less often. Heap fetches means vacuum is lagging to process. Like index-only scan worked, but heap fetches means like we need to consult heap because this page is not marked all visible, so we need to check it. But if it's all partition, most of its pages are all visible or frozen, great. So index-only scan is better. How to measure it, also interesting question for particular system. Again, it's not trivial but doable, but for arbitrary system, to find some metrics when you need partitioning. So you need partitioning 100 gigabytes. 100 gigabytes, go with partitioning. And more workers for auto vacuum. That's probably my I'm thinking about it for many years, and these reasons are not well discussed, or discussed like in very dry manner. My main reason is indexing, and secondary reason is index locality. Only then smaller index size and so on and so on.
Nice, I agree, and I also echo what you said, and I see it brought up most commonly when it comes to query performance, and I think that's one of the least good reasons for doing it. But yeah, there's lots of good reasons, and I'm glad they have net positives there as well. There are also, of course, some downsides in terms of query performance. Like we see, for example, the planner has to do some partition pruning, right? And at excessive numbers of partitions. It's getting better in later versions of Postgres for sure, but at the thousands of partitions level, you can start to see some issues there.
Planning time increases a lot. Let me again, sorry, I echo is good word. I have echo in my mind. I need to finalize my thought about why I put indexing and reindexing on the first place in terms of reasons of partitioning. In heavily loaded systems, we need index maintenance always. It should be properly planned. Without index maintenance, you will have degradation over time, 100%. It's not only about how Postgres MVCC is organized. It's for other systems, it's also so. Indexes need to be rebuilt quite often. Well, since Postgres 14, less often due to a lot of B3 deduplication in 13 and 14. But still, index maintenance is a must-have as day 2 DBA operation. And this means if you need to rebuild indexes and you have huge tables, you will have bloat, just because you are doing it quite slow, holding a smooth horizon. So index maintenance, we had an episode about it, right?
Yep.
Means also do index maintenance, but also have fast auto vacuum processing. It can be done with partitioning. These index maintenance, vacuum, and partitioning. These three components should play together. This is why I put it on the first place. I think it's underestimated reason, not well discussed in Postgres ecosystem and blogs and so on.
Nice. I think something we probably have to get to is how people might be wondering how to pick a partition key, and I think that comes it's interesting, right? In terms of have you seen it done badly, or what's your what do you generally see people doing?
There are some pains in Postgres partitioning. One of the pains that all primary key and all unique keys, unique indexes must include partitioning key. I remember I already mentioned this time when I implemented using inheritance. I implemented partitioning on some RDS system migrated from Heroku also. I remember the moment when I said, we need to index this. We had some partition key. I even don't remember. Was it a range or list or hash? I think not hash, but probably range. I don't remember. Yeah, I think range over time. And I said we need to index it as well, and like if we index it exactly like described in partitions, like with this expression, like for example date, right, from timestamp. And I was told, are you kidding? It's already partitioned by this. We don't need it, right? Postgres planner already knows how to find proper partition, and indexing on this value, it's the same. So partitioning works like some index as well, like to locate proper partition in the plan. We just use these conditions and that's it. So you don't need to have index on it. But at the same time, primary key and unique keys must have it. And this is annoying. For example, if you have surrogate key like ID, some integer, or UUID, ULID, anything, version 5, 6, I don't know, anything. Now you consider your huge table to be partitioned by range using timestamp, for example, created at, right? Now you need to redefine your primary key to have both ID column and created at column. And this is super annoying because now you think, oh, what about foreign keys, which reference to this primary key? They also need to be rebuilt. When you redefine primary key, it's also not an easy job. You need to think about if you need to do it zero downtime. Also, funny thing, I had recent experience with partitioning, and I realized if you have multi-terabyte table, and your management tells you that you can allocate up to 1 hour of downtime, it's interesting situation because you tell them back, I need either 12 hours of downtime or 0. If we have 12 hours downtime, I will design my changes in blocking manner, not online manner. So alter table, create index, because create index is like roughly 2 times faster than create index concurrently. But if you tell me I have only 1 hour, it's nothing for me. I will go with online operations and I just need more time to develop and test it. So this is funny thing, like you cannot be in the middle between huge chunk of downtime and 0. So if you like 1 hour is not good, okay, 0 downtime means we need to do some preparations, and one of preparations is to redefine primary key and unique key. All unique keys, you might have multiple ones, to include partitioning key. How to find, you asked actually different thing, how to find proper partitioning key. It's tricky, very tricky question, and also granularity. For example, okay, it's obvious that we need to have, how come we discuss time-based partitioning and didn't mention timescale?
Yeah.
Because
we haven't discussed how you create partition. Like, I think one of the main benefits of the way timescale do things is
automation.
It's exactly. Everything's done for you. Even you don't even. So we've already talked about partitioning being transparent to the user, but timescale almost make it transparent to you as the developer as well. It's so good.
Easier for you to use. Yeah.
Yeah. Exactly.
And also compressing old partitions with like 50x compression. It's super cool. This was what regular Postgres lacks. But if you're on RDS, you cannot use timescale because AWS and timescale company don't have contract for it.
Well, but pgPartman is like there are for.
Okay, but sorry, but it doesn't provide you compression and it doesn't automate in many cases. For example, I'm not sure about RDS, but on Cloud SQL, Google, you can read that. Okay, we have pgPartman, but we don't have scheduler, this like background worker or something. So automation should be handled like you need to use pgcron or some other cron jobs or something. So it's not full automation, it's just some functions, and I can write myself these functions with my logic.
But this is a big thing that can go wrong with partitioning, right? Like when I've seen blog posts that mention big issues and they mention partitioning, it tends to be a new partition failed to create, and that's a downtime issue. If you get to the point that you should be, let's say it's time based, and you get to the new month or whatever you're partitioning by, and you can't, and that partition doesn't exist, you can't accept
Yeah,
inserts all of a sudden.
It's better to create partitions in advance a little bit, right?
Yeah.
And to have some code that checks everything and some monitoring in place. So definitely, when we talk like declarative partitioning hides a lot of details from the user, automates many things, but still a lot of work needs to be done. A lot of work. For example, exactly partition creation or destroy, to just like detach and destroy it, you also need to do it yourself. Or use timescale if you can afford it, if you have such preference.
I was going to raise something else. I was speaking to somebody recently who's considering partition. They're getting to the point where they think it could be useful. And I've thought of a different way of thinking about your partition key, and that might be how you would like to delete data eventually, if you want to. So by the time-based stuff's really good because a lot of people will want to delete old data eventually. But that might not be the way you want to delete data in the future.
Yeah.
Like, for example, this person, they have to delete large accounts. Like it's customer-based might make sense because when a customer cancels and they want to delete all of that data, and that by that point it might make sense to think about it by a customer instead of by time. So it's really interesting in terms of locality as well, right? If you're running a SaaS app, chances are you're going to have that data locality. If you're doing, even if you're doing larger queries, they're probably one account at a time. Nobody's looking at data across two accounts. It's all, within a single account. So depending on how you want to access your data, but I think crucially, depending on how you might want to delete your data, might be a really interesting way of thinking about that partition key.
Yeah, also I know cases when, but it was from sharding experience, but it's very close. So partitioning can be considered like a local sharding, it's to some extent. I know the cases when people chose like sharding partitioning key implemented mechanism in such a way that if, for example, it was a huge system, first of all, very big one, like a huge system. And they chose mechanism to move accounts which are not actively used to like more archived partitions and store like to let them be evicted from the caches and so on. But those which are quite active were located in like hot partitions and be present in the like working set of database. It's also possible. It's the same like you described, but not at the customer level, but batches of customers, like not batches or subsets of customers and the accounts, and all the data associated with account is moved to some inactive. Once it becomes active, it transparently automatically moves to different partitions. It's quite interesting approach, and if it's done in non-blocking manner in background, it's interesting. But like I'm not fully understanding those guys because they live at much bigger scale. It was Yandex and their mail system, but it was about sharding, and like I remember they lived like a year or so with Oracle plus Postgres, both sharded, and wow. I was asking, are you already migrated to Postgres? And they said, we use both. Let me check what's your email? We will check. And they told me, oh, you're still in Oracle. Let me press a button. In 1 minute, you're already in Postgres. If something wrong, test it. We can move back. And I love this approach because you can, for example, if you think about partitioning and you can implement, it requires some time, but it's so cool. If you can move transparently, to migrate in batches, to move back and forth and have real testing, like new schema, old schema, you moved 10% of your data, you continue testing it. If something is wrong, in like within 1 hour you can move back and everything is on old schema. This is like very solid, mature approach, right? But it requires engineering, of course.
Yeah.
And yeah. So
I'm just thinking about the I/O overhead of moving people backwards and forwards and backwards again. But of course, for the one direction, it makes a lot of sense.
But imagine it's like partitions have many clients, but you can move one single client. It's interesting. You can do it in
sure.
batch. It's flexible. Something was interesting engineered there, and they tested it during many months, checking all parameters. A lot of nodes involved, but in partitioning it's also possible. When I implement partitioning, I consider this like transparent move in batches, of course. Everything should be online. But back to the key, it's hard question. Things to consider, first of all, like data locality, definitely. Sometimes people understanding that they have time decay, time series data, they still choose list-based partitioning. They create, for example, table partitions with IDs and list-based partitioning to manage, to have better management of what is happening with partitions and so on. Even though they could do it with like range partitioning using time. So it depends.
Does that help in terms of with balancing, like keeping the partitions roughly the same? So, like, let's say you're a growing startup. Each month you have more data. Yeah. So
exactly.
You can, if you do
but
it by
also,
a day.
Like number one question should be your workload. You need to analyze your workload and understand, like, if some query doesn't have partitioning key in where clause, for example, it means that probably it will need to scan all partitions. In some cases it's fine, but you should test and understand it, right? If it's some slow query anyway, but if it benefits from some indexes, from index-only scan, can accept it runs like 10 seconds, maybe it's fine, but what will happen in a couple of years? So anyway, like adjustment of, with partitioning, most often you need to adjust application. We say it's transparent, but to benefit from it, you probably need to adjust many queries so they can definitely benefit from it. For example, if you have partitioning key, it should be present in most queries, right? To check the plans and so on.
Yeah, if not all, but yeah, that's cool.
Right. And then you like granularity, right? So day partitions or week partitions, month partitions. I like if you check timescale, we have very like. In many cases, we have small chunks, we call chunks, and many of them. But of course, it depends on Postgres version. You need to check what will happen if you have 1,000 partitions. If you go with, for example, day partitioning, in 3 years, you will have roughly 1,000 partitions, right? So what will happen with planning time? But if you prune them, old ones, maybe you will not reach 1,000 partitions, right? But in some cases, on modern Postgres, I'm actually not sure. All productions are lagging, so I don't have a good example of large system running on Postgres 15 that I can touch with partitioning. So I just learned from release notes that many improvements happened, but haven't tested many of them yet. But planning time is maybe a concern, definitely.
I've seen slides and a couple of talk recently from, I think, Christofides about running Postgres at scale. And I think the numbers he mentioned were in the region of, in the past, it was around 1,000 partitions that would really cause you issues. But nowadays, 25,000 seems to be like a threshold that has been mentioned. But yeah, I don't have direct experience with that.
We have trade-off here. We want to be below magic number 100 gigabytes for each partition, right? At the same time, we don't want to be number of partitions too high to affect planning time badly. So we need to test our system and decide where is our golden middle ground here.
And this is where the next step is, right? You've talked in the past about 100 gigabytes partition, and how big before you should be thinking about sharding?
Terabyte?
Yeah. Okay.
Well, it's also we can live with table 10 terabytes partitioned to like 100. 1,000 probably partitions and run it on one node or quite modern machine. That should be very, very good. It's doable, definitely. 10 terabytes, it's not a problem for modern Postgres and modern hardware. But if you have 50 terabytes, you should split it in one way or another, but it's another topic, not partitioning already, right? Well, we didn't touch many topics, but I hope some interesting stuff we delivered today. We need to wrap up already. So my number one number one reason is indexing and index maintenance and vacuuming as well, and data locality, second one. But number one advice is, as usual, experiment on clones. Experiment on clones, check the plans, experiment.
Wonderful. Thank you, Nikolay. Thank you, everybody, and see you next week.
Thank you, Michael. Bye-bye.
Bye.